Huh. Okay. Here we go. I think you were off. We're going to look at our textbook, page 461. Well, there she goes again. Okay, let's go ahead and get started. As we go forward from here, I'm going to tend to focus on open response type questions because that's what your exam's going to look like. So I want us to get in the habit of thinking through these type these type questions and being able to articulate a good response. So these multiple choice questions that we talked about, they're good questions, but that's just not what you're going to see on the test. So I'm not going to focus a lot on multiple choice questions. Okay, so let's begin with the first one, 7-11. And this comes from a practice test that's in your exam or in your textbook. It's very similar to what you might see on a chapter test, but it is written with an AP exam rigor in mind. So these should give you a good gauge as to how you measure up. Okay, so 7-11, you've got three graphs there that are sample statistics of several hundred samples taken from the same population. It's important to recognize they all come from the same population. And the true value of the population parameter is marked with an arrow in the histogram. So if you look down below at the bottom on the x-axis, each of the three distributions has an arrow representing the true population parameter. And the question is this: which statistic would be a better estimate of the parameter? Is it A, B, or C? So I'll let you look at those for a couple of minutes or a minute or so. Tell me which one you think. Which one do you like as the best estimate of the parameter? Okay, anybody want to give a guess?
A, because there's less variability.
Less variability and
Centered around the
it's centered around the population parameter, right? An estimate, we want both. We want two things. We want the estimator to be unbiased. In other words, the center of the estimator is close to, if not on top of, the center of the population. And the second thing we want is low variability. In other words, we want small spread or small range or small standard deviation. B and C, while B, the center of the distribution, is located over the population parameter, it has a wider spread than A. And C suffers from both being biased. Its center is not on top of the population parameter, and it has a wider variation, has more variation than A. So A is definitely the best of the three. So that's the one we pick. Okay. So that question really just helps us make sure we understand what it means to be a good estimator. Unbiased, low variability, that's what we're looking for. Okay, so the next question, the one we'll spend most of our time on today, and it talks about paying for internet service. The amount of households pay service providers for access to the internet varies quite a bit. but the monthly fee is, the mean monthly fee is $28. Standard deviation is $10. The distribution is not normal. Many households pay about $10 for limited dial-up access or $30 for unlimited dial-up access. So you can kind of get an idea of how old this textbook is. I don't think anybody pays $30 for unlimited dial-up, or I don't think any of us have dial-up anymore. But anyway, we won't, that's really not the focus of the question. And then some pay a lot more. So a sample survey asks a simple random sample of 500 households with internet access how much they pay. X bar is the mean amount. So the first question is, explain why you can't determine the probability that a randomly selected household pays for access to the internet exceeds $29. So at this point in the solution process, what are we missing that we can't determine the probability that we can randomly pick a house in the population and the probability would exceed $29. So what's missing? Well, the first thing and the main thing is we're told that the distribution is not normal. It's likely skewed to the right. Notice the way it's described. Many pay about 30. Many pay 10 for a limited amount. Some pay 30 for unlimited dial-up, but a few pay much more for faster connections. So this distribution is likely skewed to the right. And right now, we don't have any tools for taking this distribution and calculating a probability. Later on, we might develop some, but for right now, we can't attack a skewed distribution. So what's our option here? Well, our option is to take a sample. And that's what we've done. We've taken a sample of 500 households, and from that sample data, then we can begin to make some estimates. Okay, so that's where we'll start with B. What are the mean and standard deviation of the sampling distribution of X bar? In other words, what's our sampling distribution look like for the simple random sample of 500 households? Well, in that case, the good news is we can go straight to the mean of the sampling distribution is the population mean. So we can go back to our definition here. The mean of X bar is simply the mean of the population, and in this case, that equals the population mean, which is $28. So the mean of our sampling distribution is equal to our population mean, which is $28. And then the next question is, the next part of that, what's the standard deviation of X bar? Well, we could calculate it, take the standard deviation of the population, divide by the square root of n, but first we have to check to see that the 10% condition applies. Is our sample less than 10% of the population? Well, the question doesn't specifically say what size the population is. The context of the question is about people who purchase internet access. And so in today's world, that population is probably pretty big. So we're going to say that it is safe to assume that N is greater than 5,000. In other words, our population is greater than 5,000. And so we can go ahead and make this calculation. So the standard deviation of X bar is going to be the population standard deviation, which was $10. $10 divided by the square root of 500, and that calculates to a value of about 0.45 or 45 cents. Okay, so compared to the cost of the mean cost of internet service, $28, we have a pretty narrow spread, 45 cents. So it's pretty narrow sampling distribution, and we can see that because we took a very large sample. 500 is a very large sample, so it's not a surprise that we have a narrow distribution. Question C, or part C, what is the shape of the sampling distribution of X bar? And we have to justify our answer. Okay, so we know the population is not normal. It's likely skewed to the right based on what we've been told. But what can we say about the sampling distribution of the simple random sample of n equal 500? What do we know about that shape, or what can we say? Well, because the sample size is greater than 30, the central limit theorem says that the sampling distribution of X bar is normally distributed with a mean of 28 and a standard deviation of about 0.45. Now, this is not the population. This is not the shape of the population. This is the shape of the sampling distribution of X bar, which we have approximated with 50 data points. The sampling distribution of the sample means is all the possible samples of 500. We've only got one set of 500, but we're going to use that to help us estimate the shape, center, and spread of our population. So even though the real population is not normally distributed, because we took a large sample, we can now describe our sampling distribution as being normally distributed and with a mean of $28 and a standard deviation of 45 cents. And now that allows us to do what we wanted to do at the very beginning. Look at part D, find the probability that the average fee paid for the sample household exceeds $29. Okay. We can't use population data because we don't know the shape, but we can use this sampling distribution data. We can use the shape of this distribution to estimate that probability. Okay, so now we're going to calculate a z-score. You could use, if you wanted to, you could use your calculator and the normal PDF. In fact, it might be easier because what we're trying to do is calculate a probability greater than a particular value. So like always, we want to start with a sketch. I'll draw it out here. Normally distributed with, our sketch would look like this of our sampling distribution. It's normally distributed with a mean of 28 and a standard deviation of 45 cents. And we want to know the probability of being to the right of $29. Okay, we want to know the area to the right of $29. That's much larger than one standard deviation. It's even larger than two standard deviations away. So we're expecting that probability to be pretty small. But we'll go ahead and calculate the z-score. the z-score is the value we're interested in, which is 29, minus the population mean, which is 28, divided by 0.45. So the z-score is 29 minus 28, all that divided by 0.45. If we do that calculation, we can come up with a value of, I believe, 2.24. So now what we're looking for, the probability that z is greater than 2.24, that's the probability we're looking for right here. But remember, we can only get the area to the left, so we've got to take the complement of that. So that's equal to 1 minus the probability that z is less than 2.24. And if you look that up, 1 minus, if you look that up in table A, I think that value is, well, I've forgotten it, and I don't remember it. Let me turn back here really quick. 2.24, 0.9875. Yeah, that's what 0.9875. And so that probability then is the difference of those two values, which is about 0.0125, I think. Let me get back to it. Yeah, 0.0125. 0.0125. Okay, so what does this tell us? It tells us that what's the probability that a sample of households exceeds $29. So in reality, what this is telling us is that there's about a 1.25% chance that we're going to draw a sample of 500 households where the average is over $29. In other words, the next time we take a simple random sample of 500 households from this same population, there's only a 1.25% chance that that sample will have an average over $29. So if we get a sample over $29, that's going to be really, really surprising. And it makes us question whether the true population value is 28. So that's really that would be kind of a part E to this question is if a sample did have a value of $29, what does it make you think about the data you collected from the population? But that wasn't asked of us. It was really just a matter of getting to the point where we could describe the sampling distribution of the sample means from our sample of 500 households, and then using that data to calculate the probability of finding one greater than $29. And so that's it for that particular question. So what I want to do, what you'll see today is in your AP classroom, the assignment I want us to do today is a question out of our AP classroom. After the meeting here, I'll put the link up on in Google Classroom. You'll have to log in to AP Classroom, and the question is, I need to share screen first. Hold on. Let me share my screen. Okay, so the question that you should be receiving deals with calculating the pH in public swimming pools in a large county. There are two reasons that I picked this particular question. First of all, the safe zone for pH in the pools is between 7.2 and 7.8. So the first question is, what's the probability that is not considered safe? So it's outside that range, which means this is a two-tailed question, or a two-tailed problem. You have to consider it being below 7.2 and at the same time above 7.8. Okay, so that's the other thing, first thing. The second thing is, I think this will give you an opportunity to practice uploading your results similar to what you're going to experience on the AP exam. I don't want you to upload your results to Classroom. What I'd like for you to do is you could go ahead and write out your results, your answer on a piece of paper like you have been doing. Take a picture of it, but when you get this, you'll upload that picture in a JPEG format, which is fine, directly to AP Classroom. And so that should give you an experience. Really, I'm trying to make sure that your devices will all work this way, that we can upload directly from your device. So you might want to use your phone for opening AP Classroom so you can get to the picture a little bit easier. If you choose to use your laptop, then you'll have to send the picture from your phone to your laptop, or you can type your response in Word if you want, and upload that document here. That's a limit, or that's an option for you. And you notice you can upload 2 files here. So if you had to draw a picture and you wanted to take a picture of the graph, then you could do that. And then you want to type out your explanation in Word, you can do that. Or you can just do the whole thing on paper, take a picture, upload it. And then the part B here talks about sample size of 4. I won't get into the detail there. And then part C, the third reason I really wanted to do this, I picked this question, is it begins to talk about, introduces this idea of type 1 error. And in the next unit that we talk about beginning later on this week, probably Thursday, when we start inference, we'll start talking about type 1 and type 2 error. Now, right now, you don't have to have a firm knowledge of what type 1 error is. All you need to know is that the inspector's sample of 4 was outside the safe range, and therefore he concludes that they're all unsafe, when in fact, the true value is 7.5, and they therefore are in fact safe. So that's kind of what type 1 error is. You don't have to really know what type 1 error is to be able to find the probability that he's going to make that decision incorrectly. And again, you'll upload your files here through Google, not through Google, through AP Classroom. Okay. So this is kind of a trial run of what I expect you to see. I did not put a time limit on this particular question. In other words, once you start it, you have unlimited time to finish it, so you can start and stop and all of that. On the exam, you won't have that luxury. You'll be limited. Once you open the question, you'll have 20 minutes or 25 minutes to finish it. So this should be an opportunity for us to kind of practice what it's going to be like on the exam. Also, to make sure that the capabilities you have sitting where you are sufficient for you to be able to take the exam. So the assignment became available at 1 o'clock. So you should be able to log in and find it. It's called NTI Day 14, I think. I didn't make it due until the end of the week. Some of you might have questions as you walk through the steps. Feel free to send me questions via Classroom. I'll help you walk through it. This is not as straightforward as what we just talked about in class. It's a challenge question, but I think we're up to it. But if you do have questions, feel free to contact me on Classroom. I'll give you some hints along the way. So that's it for today, unless y'all have questions. Also, I'll be checking in on Classroom throughout the afternoon. Please go ahead and check to make sure you can access the question. I don't care if you have time to work on it today or not, but I do want to know this afternoon that you're having trouble accessing it. So if you do have trouble, let me know, and I'll go to work on trying to fix that one. All right. Well, stay safe in all the snow, and send me a picture of your snowman that you're building today. Haha. Remember, no school tomorrow because of the snow. Yeah, bad joke on it. All right. Well, guys, we'll see you same time tomorrow. Y'all have a great rest of the day and stay in touch. Talk to you later.